Hello curious coders, it's Bruce and the dog on the floor, and we've been working through the basic building blocks of the Elixir language. And today we come to what I believe is the most important building block, and that's the data structure. And you might think that that's a little bit strange because in a functional language, the function should trump everything, but let me tell you that data determines approach. You've got to start with the right data to wind up with the right results. Let's go. As usual, we're going to start this session in IEX, Interactive Elixir. And what I'd like to do is talk about the basic embedded data types or the built-in data types in Elixir. So to give you an idea of where we're starting with this list, I'm going to type H kernel, just so you'll be able to know how to fish. You'll be able to find this data on yourself. So if I scroll on up, I can see that these are the basic built-in data types of Elixir. And there are a couple of them on the second part. There's the special forms that looks like this, but this is basically what a string is built on. And then there's an idea of a reference, and that's just an uber unique value in the system that's going to make it easier to build things like distributed systems. We're not going to talk about this one, and we're not going to talk about ports either, because ports are mechanisms to build integrations with external systems, and that's a little bit advanced for us. But we'll talk about most of the rest of these. So let's start to work through them. Let's start with an atom. Now, atoms are names for things, and they will typically begin with a colon, like this. And we'll use lowercase and snake case for atoms. We might see atoms represented in a slightly different way in the system. Since I already said that atoms are names for things, well, kernel is the name of a module, and it's also the name for something. And if I get more information about this term, this last value that's been created, I can type I, and I can see, oh, this kernel is also an atom. So there's another way to create an atom. That is with camel case, potentially with dots between. That's another valid way to express an atom. And one of the things that you'll see in Elixir is sometimes if I have a list of keys and values, you'll see in the key, the colon flip to the other side. Don't let that throw you off. In this case, this key is also just another representation of an atom. So atoms are names of things, like this key, like this module name, and we will often use these in place of strings to label our concepts in Elixir programs. The next data type that we're going to talk about is a number. So both 1, you can see that this is an integer, and 1.2, and you can see that this is a float. These are the two primary types of numbers that we'll use, though you might see in other Elixir frameworks like NX. NX is the numerical computing for Elixir, and it brings in more specialized data types that are also numeric. This 1 and then this 1.2 are numerical types, and there are also different representations. So I can have underscores in it. So for example, if I have 1,000,000, these underscores do nothing to change the value, they just change the legibility. And you can also, if you are a programmer at heart and you know about other number systems, well, I can have a 0B, and then I can specify numbers in ones and zeros. So for example, 1, 2, 3, 4, 1, 2, 3, or 1, 2, 3, 4. This should give me a binary 15. And it does. So this is counting up with a number system that has only digits 0 and 1. So these are numbers. Next are some more complex data types. Like for example, if I have a list of terms that looks like this, and this is one represented as a number, an atom, and a string. So this whole thing is called a tuple or tuple. Both of them work just fine. And this tuple is typically used in Elixir to represent short sequences of fixed length where the types need not be the same. So for example, I might have something like Austin, Texas. That's a place. Or I might have a coordinate like the origin at 0, 0. So typically, I don't need to access elements in this tuple randomly. So I'll use a function to access the elements in it. So for example, I could say element, let's have this, and I want the 0th element, which is that first one, and this is going to give me Austin. So that's a tuple or a tuple. You'll hear me pronounce it both ways. And then if I have longer lists, or potentially longer lists of variable size, where the types are generally the same, I'll use a list. So for example, this comma separated list of values is a list. There are two ways to represent key value data, and the first one is just by combining tuples and lists. So for example, I could have something like this. I could have 1, 1, 2, 2. And watch what happens here. So this is another way to represent the exact same concept because it shows up so often in Elixir. So this is the same as this. There's one more way to represent key value data in Elixir that's one of the basic data types, and that's the map. And I can steal this same representation, or I can use the longhand key, and this is called a hash rocket. And then I could have the key, and this is called the hash rocket. And if all of the keys are atoms, you'll see this rewritten into a more concise form that looks like this. But this and this are the same. So these are the ways to represent key value. This one is called a keyword list, and the second one is called a map. We're excited to have you come along with us on your learning journey. If you want more insights like the one you just saw, come to Groxio and subscribe for a deeper dive where you can find more topics and videos to support your learning needs. I want to talk a little bit about how to represent character data in Elixir. So typically, characters are represented using the Unicode representation. Now, Unicode is a standard that assigns numbers to various letters. So for example, an A is a 97, a B is a 98, and so on and so forth. But if I put a bunch of those things together, and that's this here, rather than building a linked list, this is just numbers compiled back to back into memory. This is an A followed by a B. I'm going to get a string representation. So you could see that this thing is a bit string, and it's also a string because all of the characters that are in it are printable. So I realize that some of this might be a little bit advanced for you, but that's okay. You've seen this before now, so if you need to go back and do a little bit of research, this thing is called a bit string. And I want to tell you this because in IEX and other Elixir tools, the tooling underneath might not be able to tell the difference between, for example, a bit string and a string. But if I'm working with character data in string form, I'm typically going to use this library. So for example, I might say string dot duplicate, and I might want to duplicate the D 4 times. Right? So this is the module for dealing with binary data that is in the character range. And this is shorthand for this. So that's string data. You might also come across the concept that there are a list of printable characters. And remember, these brackets, this is a linked list, which means that each element of the list has its own value and then a pointer to the rest of the list. And they're kind of chained together, and they might not be in contiguous memory, and often they're not. But so, for example, if I had the printable characters A, B, and C, you'd see something that looks like this. This is not a string. These are not the same. ABC, is that the same as ABC? That's false, because this first one is a list, and this second one is a binary. So these are the two ways to work with character data in Elixir, and by far the most efficient and the most common is the string. Now the last built-in data type that we'll talk about might surprise you a little bit. It's a function. So for example, I might want to do something with everything in a list. So I might have this list, and I might have to tell Elixir to do something to everything in the list. So in Elixir, the function to do that is a map, and it has 3 arguments, and one of those arguments is a function. So I'm going to say my function is toString. But I have to tell Elixir, hey, I don't want you to execute this function yet until I give it to enum.map, which is what we're going to use to do something to everything in this list. So I have to have a shorthand. And remember, I need to be able to tell it not just the name of the function, but the number of arguments. So toString has 1 argument. And to tell it that this is a function and I want to delay execution, I'm going to put this ampersand in front of it. So now I can do this. I can say enum.map, and it's going to take a list. And then now I can pass it this data type. This is a function. And this is what makes Elixir a functional programming language, or at least one of the things. And you can see that these are not integers anymore. These are wrapped in quotes. These things are strings or binaries under the hood. And so working with functions in this way is going to be convenient because it's going to allow us to process much more complicated things with a much more concise code footprint. And that's really what makes functional languages great. So we've gone through the major Elixir data types. We started with the idea of an atom, and then we cruised down through numeric values, and then we worked through tuples and lists, and then we worked through key value data and character data. And finally, we spent a little bit of time working with functions as data values. So Elixir has a very robust starting point for dealing with data. That's going to go a long way. That's an excellent thing. From Bruce and the dog on the floor, this is Squawksio Learning.